Hey guys, today we're going to learn about, or the video I'm gonna do here is going to be talking about how to add and subtract numbers that are in scientific notation. So last week we did a lot of stuff with just basic scientific notation of how to write a number in scientific notation, or how to take a number from scientific notation and write it out in standard form or as a regular number. Okay, so today obviously we're going to start taking the next step with that, and that's what we're going to do this week. Is we are going to learn how to add, subtract, multiply, and divide in scientific notation. So I will give you a warning here. Adding, subtracting, believe it or not, is actually, in my opinion, it's more difficult to add and subtract in scientific notation than it is to multiply and divide. Okay, and you'll probably see that once we get through this week and you do this stuff here with this. And I like to compare this very much to fractions. Okay, so when you add and subtract fractions, what's the biggest thing we have to do or have to be able to do in order to do it? We have to find a common denominator. Okay, so if you go back to sixth grade, fifth, sixth grade, whenever that was, when you learned how to add and subtract fractions you learned how do I find a common denominator, because if you don't have a common denominator, you can't do anything. So the similarities here with that is, you might think, how does that compare? How does this compare to fractions? Is in order to add or subtract numbers in scientific notation, they have to have the same exponent. Okay, they have to have the same exponent. So if they don't, when they do have the same exponent, then it's a very simple process of adding and subtracting them. When they don't, then it's going to be, it's going to be really difficult, and we can't really do it, especially unless we have like a calculator, or if we take the numbers and write them all the way out into standard form. It's complicated. It takes too long. Okay, so here's what we're going to do. So the best thing to do is for these, just like when you have a common denominator, there's obviously there's more than one way to do it. There's more than one way to go, but there's usually kind of the best way to go. So with fractions, it's finding the least common denominator. Okay, so for these, the best thing to do is to take the smaller exponent and change it to the bigger exponent. Okay, so that means I'm going to take this one. I'm going to take my 10 to the 7th power, this number, and I'm going to rewrite it so that it's 10 to the 8th. That also means that I'm not touching this one. So I'm just going to rewrite it down here because I know I'm leaving that one alone. This one, I'm going to change to 10 to the 8th. Okay, so again, let's stop and think for a second. What does this mean? What is up here? What does 10 to the 7th power mean? Well, that would mean that I would take my decimal and move it 7 spots to the right if I wanted to write it out as an actual number. So if I want to change that to be 10 to the 8th power, how will that change that number? How will that change that 2.9? Okay, well, I added 1 to the exponent, right? So instead of going 7 spots to the right, now I'm going 8 spots to the right. So to make that equal, or make that the same number, then that would mean I would take my decimal and move it back 1 spot. Okay, so now when it was 2.9 times 10 to the 7th, my decimal goes 7 spots to the right. 0.29 times 10 to the 8th, my decimal going 8 spots to the right. If you look at those two numbers, they would actually end up being the same thing. The decimal would end up being in the same spot. It would be 29 with 6 zeros at the end of it, both ways. Okay, so now, excuse me, now since both of these are 10 to the 8th, let me get my highlighter again. Both of these are 10 to the 8th. We're good to go. Now all we got to do is take what is 0.29 plus 7.2, and that you can grab a calculator if you want to do it by hand. It's pretty quick and easy. But that would be 7.49 times 10 to the 8th. And we're done. Okay, 7.49 times 10 to the 8th. Now, the only thing that can be a little tricky with these, okay, is this. Let's change the numbers here just a little bit. Okay, just to make this to show you. So you can rewrite this example, but I'm going to leave everything with the exponents. I'm going to leave those the same. I'm just going to change these numbers real quick. Okay, I'm going to make this 9.2 instead, and I'm going to make this number, let's say 9.6, something like that. Okay, which would make this 0.96 if we move it back. Whoa, that's ugly. 0.96 there if we move it back. Okay, so instead of doing a whole entire new problem, it'd still be the same thing. So let's see what happens with this one. So when I take 9.2 and add 0.96 to it, and I'm going to make sure I don't mess this up, so I'm going to grab my calculator real quick. 0.96 plus 9.2, I got 10.16. Okay, now this is the only time that it can get a little tricky is this number. Remember, that number has to be between 1 and 10. Okay? It is not between 1 and 10 anymore. It's a little bit more than 10. So to simplify this, I need to move the decimal back one spot to make this 1.016 so that it's in scientific notation. Now, since I move my decimal back one spot, then I'd have to change my exponent of 1. Okay? So adding and subtracting a lot of times can be pretty simple, but the only thing you got to be careful of, especially with adding, probably not so much with subtracting, but especially with adding, is you got to make sure that number in front is between 1 and 10, because sometimes when you add those two numbers together, it's possible that it could be more than 10. Okay, let's look at subtraction. Even though subtraction is the exact same idea, where we have to have the same exponent, these don't have the same exponent. So again, we got to change them. Always change just like this one. What do we do? Change the smaller to the bigger. Same thing here. I want to change the smaller exponent to the bigger one. So I'm going to leave this as 9.04 times 10 to the 9th since that's the bigger one. I'm going to change this one to 10 to the 9th. And just like up above, if it's 5.3 times 10 to the 8th, it would go 8 spots to the right. So if I'm going to make it go 9 spots to the right instead, that means I would have to make it 0.53 for my number. That way, these two numbers are still the same. Again, just like when you change your fractions, when you find your common denominator. When I find my common denominator, I don't just change the denominator, right? I got to also change the numerator, otherwise they're not going to be equivalent anymore. Same idea here. So now I just got to figure out what is 9.04 minus 0.53, since my exponents are the same, and that's 8.51 times 10 to the 9th. And probably 99.9% of the time, if you're subtracting, that number that you get when you subtract is probably going to be between 1 and 10. I'm not going to say every single time because it's really hard to say that in math, but that, especially for us, the vast majority of the time, they are going to be, when you subtract, they're going to be good to go. Adding, maybe not. So be careful with that. All right, so watch this game if you need to. Like I said, hopefully make sure you write down these notes. Not much to write down here, but it's going to help you remember these things for the assignment that we'll probably have over this stuff probably tomorrow. All right, have a good day. Let me know if you need anything.